Today we're going to talk about trig ratios on the coordinate plane. And so we're going to start by reviewing our quadrants of the coordinate plane. And so this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Now I wrote it in Roman numerals, but I'll write it in red with normal numbers. So if we go to an example, so we have secant of theta equals 2. Theta is in quadrant 4. What are the other 5 trig ratios? So we're going to start with drawing ourselves a set of axes. And we know that theta is in quadrant 4. And so this is quadrant 4. And so we're going to draw ourselves a triangle going out from the origin and then straight to the x-axis. And theta is right there. And so what we want to do is we want to think about how secant of theta is going to be equal to the hypotenuse over the adjacent side because it's the reciprocal of cosine. And so if it's equal to 2 over 1, then the hypotenuse would be 2. And the adjacent side would be 1. And so step 1 is going to be solve for the missing side of your triangle using Pythagorean theorem. So we have Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. So that means this is going to equal 2 squared. We can pick if we have a or b, so I'm going to leave b squared. And then a would be 1 squared. So that gives us 1 plus b squared equals 4. If we subtract 1 from each side, that gives us b squared equals 3. And then we're going to take the square root of each side, which gives us b equals the square root of 3. But we want to keep in mind that if we go over here to our triangle, this is actually going down on that side, which means that needs to be a negative square root of 3. So now step 2 is going to be find the other 5 trig ratios. And so that means that we're going to need to find sine of theta, cosine of theta, cosecant of theta, tangent of theta. I'm going to reorganize these actually. I'm going to put tangent of theta third, then cosecant of theta, and then cotangent of theta. So sine of theta is opposite over hypotenuse. So I'm going to look back up here and we're going to label opposite of theta here is our negative square root of 3. Adjacent is going to be our 1, and the hypotenuse is going to be our 2. So opposite is negative square root of 3 over the hypotenuse of 2, and that cannot be simplified, so it's done. And then cosine is adjacent over hypotenuse, so it's going to be 1 over 2, and that cannot be simplified, so that's also done. Tangent of theta is going to be opposite over adjacent, so it's negative square root of 3 over 1, which we can just write as the negative square root of 3. Then we have cosecant of theta, which is the reciprocal of sine, so we're going to take our sine fraction and write the reciprocal, so that's 2 over the negative square root of 3. But we have this radical in the bottom, so we need to rationalize the radical by multiplying by the square root of 3 over the square root of 3. And then we get 2 square root of 3 over negative square root of 3 squared. And the squared and square root cancel. And that gives us 2 square root of 3 over negative 3. And so now we go to cotangent of theta, which is the reciprocal of tangent. So that's going to be 1 over the negative square root of 3. Again, we have a radical in our denominator, so we need to rationalize. And that gives us 1 times the square root of 3 is the square root of 3 over negative square root of 3 squared. The squared and square root will cancel, and so that leaves us with the square root of 3 over negative 3. Next, we're going to look at angles of elevation and depression. And so if I draw a little person just to kind of help us out. And so from their eyes, I'm just going to draw in what their regular straight out line of vision would be. And then the angle of elevation would be going up here. So from that line up is going to be your angle of elevation. And then from that line down is your angle of depression. So now if we do an example, so a tree casts a shadow of 532 feet. Find the height of the tree given the angle of elevation to the sun from the ground. Is 25.7 degrees. So I'm going to draw a picture. So we have a tree. And this tree casts a shadow. And then we have a sun. And so we're looking for the angle of elevation from the ground to the sun. So that'd be from the ground to the sun is our angle of elevation. And we know that it's 25.7 degrees. It tells us that the tree to the end of the shadow is 532 feet, and we want to find the height of the tree. So the height of the tree is opposite of our angle given, and 532 feet, or the distance of the shadow, is the adjacent side of our angle given. And so when we have opposite and adjacent, when we think of SOHCAHTOA, the tangent here is the one that uses the opposite and adjacent side. And so we're going to say tangent of the angle is going to be equal to the opposite side of h over our adjacent side of 332. Now we want to get h alone, so we're going to multiply each side by 332, or 532, sorry. And so that gives us 532 times the tangent of 25.7 degrees is equal to h. Now you want to make sure that your calculator is in degree mode, so make sure you hit the mode button and have degree highlighted. If it's not, push the arrow down to radian and degree, and then push over to highlight degree, and then press enter. And then you can quit out and you're good. And so you're going to take all of this and you're going to type it straight into your calculator. And you're going to find that the height is approximately 256.03 feet tall. So lastly, we're going to look at finding a missing angle. And so if we have theta there, and this is 4, this is 3, and this is 5, we want to try to find that missing angle. And so you want to make yourself a little note here that you always use the inverse function to find your missing angle. And so what I mean by that is you're going to use the sine inverse of your opposite over hypotenuse, or you could use the cosine inverse of adjacent over hypotenuse, or you can use tangent inverse of opposite over adjacent. And so here we're given all three sides, so we can pick which one we want to use. So I'm going to use sine, and so opposite is here, and your hypotenuse is here. And so we're going to say that the sine inverse of our opposite side over our hypotenuse side, and you just type that straight into the calculator by pressing the second key and then the sine key, and you're going to find that's approximately 36.87 degrees. I'm actually going to throw in one more example if we want to find a missing side. So if we do this, and if we're given the angle measure of 30 degrees, and let's say this is 3, and then we want to find x. So this is the opposite side, this is our adjacent side, and so if we think back to SOHCAHTOA, that's going to be tangent. So we're going to say tangent of 30 degrees is equal to the opposite side over our adjacent side. Now if we want to think of this as a proportion, so over 1, we can cross multiply everything. So we do x times tangent of 30 is equal to 1 times 3. And then we're going to divide tangent of 30 on each side. And so that's going to give us x equals 3 over tangent of 30. And since we're using degrees, we want to make sure that our calculator is in degree mode, and we're going to type this directly into our calculator. And you're going to find that x is approximately 5.2.